In the heart of North America, beneath the vast forests, bubbling geysers, and majestic mountain ranges of Yellowstone National Park, one of the planet's most formidable sleeping monsters lies dormant. This is not a classic volcano with a sharp peak and a wisp of smoke. This is a supervolcano, a massive caldera hidden beneath the Earth's crust, ready at any moment to remind humanity who the real master is here. Scientists from the National Geographic Society, the BBC, and the U.S. Geological Survey have been monitoring it for years, filming documentaries and running scenarios that make even the most skeptical experts pause. What will happen if Yellowstone wakes up? A global winter, ash storms, famine, and chaos capable of changing the course of civilization. Supervolcanoes are volcanoes of the highest category on the Volcanic Explosivity Index, or VEI. They do not just erupt lava, they eject thousands of cubic kilometers of magma, ash, and gases in a matter of days. For comparison, the eruption of Vesuvius in 79 AD, which buried Pompeii, had a VEI of 5. The 1883 Krakatoa eruption was VEI 6. Supervolcanoes are VEI 8. The volume of material ejected exceeds 1,000 cubic kilometers. Such events occur extremely rarely, on average once every tens or hundreds of thousands of years. But when they do happen, the entire planet feels the consequences. The Yellowstone supervolcano is one of the most studied and most famous. Its history stretches back 2.1 million years. Geologists have reconstructed 3 colossal cycles. The first supereruption occurred about 2.1 million years ago. More than 2,450 cubic kilometers of material burst from the depths, thousands of times more than the 1980 Mount St. Helens eruption. Ash blanketed nearly the entire territory of the modern United States, reaching as far as Louisiana and Missouri. The Earth's crust collapsed, forming a giant caldera more than 75 kilometers long. The second eruption, 1.3 million years ago, was slightly smaller but still catastrophic. The third, the most recent in geological terms, happened approximately 631 to 640,000 years ago. It ejected about 1,000 cubic kilometers of Lava Creek tuff and created the modern Yellowstone caldera, 45 by 85 kilometers. After each such event, the landscape changed forever. Rivers were rerouted, lakes appeared where mountains had collapsed, and ash fertilized the soil for thousands of kilometers around. Today, Yellowstone looks peaceful. Millions of tourists each year photograph Old Faithful, the Norris geysers, and the multicolored hot springs. But beneath the park, several kilometers underground, lies a huge magmatic chamber. According to seismological studies, it is filled with magma by only 5 to 15%. The rest is solid rock. That is why scientists at the Yellowstone Volcano Observatory, YVO, emphasize the probability of a supereruption in the next few thousand years is extremely low. The volcano is not overdue. The intervals between major eruptions ranged from 600 to 800,000 years, and only about 640,000 years have passed since the last one. Monitoring is conducted around the clock. Thousands of seismometers record earthquakes, on average several dozen per month, but weak ones. GPS stations measure the slightest uplift and subsidence of the ground, and satellites track thermal radiation. As of spring 2026, the level of activity remains normal, green code. Recent minor uplifts on the northern edge of the caldera have stopped, and earthquakes are at background levels. Nothing alarming. However, scientists do not relax. They know that supervolcanoes can be deceptive. Magma can accumulate slowly for decades and then explode suddenly. Recall other supervolcanoes on the planet. Indonesia's Toba, about 74,000 years ago, released up to 2,800 to 3,800 cubic kilometers of material, the largest eruption in the last 2 million years. Ash and sulfur aerosols rose into the stratosphere, reflected sunlight, and triggered a volcanic winter. Temperatures dropped by several degrees across the planet for years. Some researchers link this event to a sharp reduction in human population, a bottleneck in genetic history. New Zealand's Toba is the youngest supervolcano. Its last VEI 8 eruption, Orua Nui, occurred just 26.5 thousand years ago. It too changed the climate and landscape of an entire region. What will happen if Yellowstone repeats the scenario of the past? Documentaries by National Geographic and the BBC, such as the 2005 film SuperVolcano, attempt to show this with scientific accuracy and dramatic intensity. Let's imagine a hypothetical day of awakening. First, the signs. Weeks or months before the catastrophe, seismologists will record a swarm of earthquakes. Magma will begin to rise, causing swarms of tremors with magnitudes of 4 to 6. The ground on the northern edge of the caldera will start rising at a rate of several centimeters per day. Geysers will become more active, and new thermal springs will appear in Biscuit Basin and Norris. Scientists will declare elevated alert status. Tourists will be evacuated from the park. The U.S. government will impose a state of emergency. Then, the beginning. At some point, the pressure in the magmatic chamber will exceed its limit. The Earth will shake so violently that it will be felt even in Denver and Salt Lake City. The first explosion, the Plinian phase. A column of ash and gas will shoot 30 to 40 kilometers into the sky. The sound will be heard thousands of kilometers away. Pyroclastic flows, clouds of gas, ash, and rocks heated to 600 to 700 degrees Celsius, will race forward at speeds of up to 100 kilometers per hour. Within a radius of 100 to 150 kilometers from the caldera, everything will be destroyed in minutes. Trees will burst into flames, buildings will vaporize, and roads will melt. Yellowstone, Jackson, and parts of Montana, Idaho, and Wyoming will turn into a dead zone. Ash will spread farther. In the first hours and days, it will cover the Midwest of the United States with a layer tens of centimeters thick. Airplanes will be grounded. Ash destroys engines. Electricity will fail due to short circuits. Water in rivers and lakes will become unusable. Millions of people will find themselves in the direct danger zone. According to models, ash will reach the east coast of the United States, Canada, and even Mexico. And then, the global effects. Sulfur ejected into the stratosphere will turn into sulfuric acid aerosols. They will reflect sunlight, and global temperatures will drop by 3 to 10 degrees Celsius, according to various models, for 6 to 10 years. A volcanic winter will set in. In the northern hemisphere, summer will turn into a prolonged autumn. Wheat, corn, and rice harvests will collapse. Famine will grip billions. According to some estimates, hundreds of thousands of people in the United States alone will die from the immediate consequences, while worldwide, tens of millions will perish from hunger, disease, and mass migrations. The sky will darken, as in the year without a summer of 1816 after Tambora, only hundreds of times worse. Scientists emphasize this is not the end of the world. Humanity survived after Toba and Taupo. But civilization as we know it, with global trade, air travel, and megacities, will change forever. The ash will eventually fertilize the soil, but the first decades will be harsh. New forms of life will appear on the ash fields, just as they did after previous eruptions. While Yellowstone remains at a calm, green alert level, scientists around the world are studying other supervolcanoes to better understand the mechanisms behind such catastrophes. In Indonesia, on the island of Sumatra, lies Toba, the most powerful known eruption in the last 2 million years. About 74,000 years ago, its eruption ejected between 2,800 and 3,800 cubic kilometers of material. Ash several centimeters thick covered even the Indian subcontinent. Enormous volumes of sulfur entered the stratosphere, forming aerosols that reflected sunlight. A volcanic winter began, lasting, according to some estimates, from 6 to 10 years. Temperatures dropped by several degrees across the entire planet, leading to crop failures, forest die-offs, and mass extinctions of animals. For a long time, it was believed that Toba had nearly wiped out humanity, causing the so-called genetic bottleneck. Geneticists found traces of a sharp reduction in DNA diversity among modern humans around that period, supposedly down to just a few thousand survivors. However, new research conducted in the 2000s and 2020s has cast doubt on this theory. Archaeological finds in South Africa show that people continued to live and even thrive along the rich coastlines, where the ocean provided food. Genetic data now more often link the main narrowing of the population not to Toba, but to earlier ice ages or migrations out of Africa around 50 to 60,000 years ago. Nevertheless, Toba remains a striking example. Even if humanity did not go extinct, the global climate changed for millennia, and ecosystems had to rebuild from scratch. In New Zealand lies another young supervolcano, Taupo. Its last super eruption, Oruanui, about 26,500 years ago, was one of the most powerful in recent geological history. Today, the caldera is filled with a huge lake, but activity continues beneath it. Earthquakes, deformation of the lakebed, and changes in gas composition. Scientists model that a new major eruption could once again blanket a significant part of the country with ash and affect the climate of the southern hemisphere. No less concerning is Campi Flegrei, the Phlegrean Fields, beneath Naples in Italy. It is not a classic supervolcano, but its caldera is enormous, and its history includes powerful eruptions. In recent years, increased seismic activity has been observed here. Thousands of small earthquakes, ground uplift, and gas emissions. Scientists are using artificial intelligence to analyze the data and distinguish normal breathing activity from precursors of a real eruption. So far, the threat is assessed as local, but the densely populated region makes any scenario extremely dangerous. In California, Long Valley sleeps, another ancient caldera that formed 760,000 years ago. It too shows signs of resurgence, slow uplift of the floor, earthquake swarms. However, like in Yellowstone, the magmatic chamber is mostly solid rock, and the major eruption is considered highly unlikely in the coming millennia. Let's return to Yellowstone. What exactly will happen if the magma finally breaks through? Modern computer models developed by the U.S. Geological Survey and other institutions provide a more accurate picture than the dramatic films of the 2000s. The eruption will not begin instantly. For months beforehand, seismologists will record thousands of earthquakes. GPS stations will show accelerated ground uplift, not just centimeters, but tens of centimeters per day. Geysers will erupt with unprecedented force, and new hot springs will appear in unexpected places. Scientists at the Yellowstone Volcano Observatory will raise the alert level to yellow or orange. Tourists will be evacuated and roads will be closed. When the pressure becomes critical, the first explosion will be colossal. A column of ash and gas will shoot up to a height of 30 to 50 kilometers. Pyroclastic flows, deadly incandescent avalanches, will destroy everything within a 50 to 100 kilometer radius in a matter of minutes. Their speed can reach 100 to 200 kilometers per hour, and their temperature 600 to 800 degrees Celsius. Nothing living will survive in this zone. The ash will be carried by the winds. Models show an umbrella cloud spreading in all directions. In the first days, the Midwestern United States will be covered with a layer of ash from 10 centimeters to a meter thick. Buildings will collapse under the weight, agriculture will be paralyzed, and airports will be closed for months. Ash destroys aircraft turbines. Power grids will fail due to short circuits. Water in rivers and lakes will be contaminated with toxic substances. Global consequences will follow in the weeks afterward. Sulfur in the stratosphere will turn into sulfuric acid aerosols that will reflect sunlight back into space. According to various models, the average global temperature will drop by 3 to 10 degrees Celsius for a period of 6 to 10 years, and in the northern hemisphere by as much as 12 degrees Celsius. Summer will turn into a cold autumn. Harvests of wheat, corn, rice, and soybeans will plummet. In countries dependent on food imports, famine will begin. According to the most pessimistic estimates, tens of millions of people could die from hunger, disease, and the chaos of mass migrations. The sky will turn gray, solar panels will lose efficiency, and plant photosynthesis will slow down. However, scientists emphasize an important point. This is not the end of humanity. After past super eruptions, life returned. Ash, rich in minerals, will eventually make soils incredibly fertile, just as it did in regions around ancient calderas. New plants and animals will colonize the dead zones. Humanity, equipped with modern technology, knowledge, and international cooperation, has a better chance to prepare than ancient people did after Toba. How should we prepare? Monitoring is the key. The network of seismometers, GPS, satellite observation, and gas analyzers in Yellowstone is one of the best in the world. Scientists are confident a major eruption will provide months or even years of warning. Governments are developing evacuation plans, food stockpiles, and alternative energy sources. International organizations are discussing scenarios for global food security in the event of a volcanic winter. In documentaries such as National Geographic and BBC's SuperVolcanoes, one idea often stands out. Volcanoes are not only about destruction. They created Earth's atmosphere, fertilized soils, and made life as we know it possible. Without volcanic activity, the planet might have remained cold and lifeless. Yellowstone, Toba, Taupo, and others serve as a reminder of the power of the Earth and our own fragility. Today, in the spring of 2026, Yellowstone sleeps peacefully. The alert level is normal, green. The recent ground uplift on the northern edge of the caldera, which began in July 2025, stopped by mid-January 2026. Earthquakes remain at background levels, several dozen per month and week. The geysers continue their usual eruptions, delighting millions of tourists. Scientists continue to monitor, collect data, and improve their models. They know the probability of a super eruption in the next few thousand years is extremely low. But preparedness is what distinguishes modern society from ancient hunter-gatherers. Supervolcanoes teach us humility before nature and, at the same time, respect for science. While the giants slumber, humanity has time to learn, prepare, and appreciate the fragile balance in which we exist on this fiery planet.